Hey guys, today we are doing 1.3 part 2 of the notes. So before we start with in behavior, there are two things I want to discuss with you. Okay, the first is what our graphs look like depending on our leading coefficient, leading term. Okay, so if we have an even exponent, okay, and a positive leading coefficient, then our graph is going to create the U shape. If we have an even exponent and a negative leading coefficient, then it will go down. So for example, this could be y equals x squared, where this one could be y equals negative x to the fourth. Okay, and then if we have an odd exponent, if it's positive, it starts on the right and goes to the left. So for example, y equals x cubed. Okay, and if it's a negative, starts on the left, goes to the right, so y equals negative x to the fifth. Okay, this is really important to help you understand in behavior because we're looking at where our graph ends and in what direction it's heading. Okay, so when it's even and positive, they're both going to infinity. But if they're even and negative, they're both going to negative infinity. And if it's odd and positive, the right side thinks this is the middle. The right side is going to infinity, but the left side is going to negative infinity. And here it's the opposite. The left side goes to infinity, and the right side goes to negative infinity. Okay? So this is super helpful for what we're about to do, okay? When describing end behavior, we're looking at where the graph is going. So like I said, you want to always look at the highest power and its leading coefficient, okay? So in this case, it's a negative x squared. It is an even with a negative coefficient. So the graph is gonna go down like this, okay? And how we write in behavior, we say as x is approaching infinity, f of x is approaching blank. As x is approaching negative infinity, f of x is approaching blank. So what do we look at? We look at our graph. Here's the middle of it. And think of a typical number line, okay? This is our 0 here. We're going to positive infinity to the right and negative infinity to the left, okay? So as x on our number line is approaching positive infinity, our graph is going down towards negative infinity. And as x is approaching negative infinity, so our x-axis here, approaching negative infinity, our graph is going down to negative infinity. Okay, and that's all we're looking for. So same thing here. As x is approaching infinity, f of x is approaching blank. As x is approaching infinity, f of x is approaching blank. Okay, now if we were to FOIL this out 3 times, our power would be x cubed. This is a positive, so starting on the right, going to the left. Okay. Remember our number line here. 0. X-axis here, going to positive infinity, negative infinity. Okay. And then our arrow on the right as we're going to positive infinity. So as we're going to the right here, our arrow is going up to infinity. And, oops, I forgot my negative there. As we are going to negative infinity and following the line left, we're heading down to negative infinity. Okay. As x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. If we were to distribute this in, we would get negative 1/2 x to the 4th. Okay, this is an even exponent with a negative coefficient, so it is going down. Here is our 0. Here is our x-axis. Okay, as we follow the graph to the right, positive infinity, we're heading to negative infinity. And as we are going to the left, we're going to negative infinity, going down. Okay. Last one, as x approaches infinity, f of x approaches blank. As x approaches negative infinity, f of x approaches blank. If we were to distribute this in, we would get a negative 3x to the 5th. This is an odd function going negative, so it looks like this. Okay, here's our number line, 0, 0, positive, negative. So as we're going to positive infinity, it's going to negative infinity, and as we are going to negative infinity, we're heading to positive infinity. Okay, that is end behavior. Now we're talking about average rate of change, AROC for short, okay? AROC is also basically slope. Slope, we know the slope formula, okay? Slope is y2 minus y1 over x2 minus x1. This is slope. We just use fancier letters here. F of x minus f of c over x minus c, okay? So what we're doing when we find an average rate of change, we are finding it over an interval of numbers. So we are finding it from 1 to 3. Now, these are both of our x values, x1, x2. We need to find our y values. So what do we do first is find f of 1 and f of 3, okay, to get our y values. So plug in 1 cubed minus 3 times 1, which is 3 minus, oops, not 3, 1 minus 3, which is negative 2. So we have 1, negative 2. And then 3 cubed minus 3 times 3, 27 minus 9, 18. So 3, 18. Now that we have x1, y1, x2, y2, we can find AROC, which is y2 minus y1, so 18 minus negative 2 over 3 minus 1, 20 over 2, 10. So 10 is our answer. Okay, that is AROC, average rate of change. Okay. It is a secant line going through 2 points and a curved line. Okay. So comparing functions and interpreting graphs. Okay. So we're going to write a mathematical statement for functions of f and g to represent each verbal statement. Use function notation f of x and g of x as well as appropriate symbols, less than, greater than, equal to. Okay. A point x comma 0 is located on the graph of f. So if it's on f, f of x, because x is equal to 0, that's our y value. Easy enough. Two functions f and g intersect at a given point. Okay, well, if they're intersecting at a given point, then they would have the same y value. So f of x equals g of x. A point lies above the x-axis on function g. So g of x is greater than, not equal to, 0. Because if we're above the x-axis, which is 0, then we got to be greater than it. Okay? A point lies below the x-axis on the function f. So f of x is less than 0. The graph of f lies above the graph of g. So if it's f is above, so greater than g. The graph of f lies below, so f of x has to be below g of x. Okay, not too bad interpreting the information. So, function operations with multiple representations. Okay, we have two things given to us. We have f of x on the graph. So this whole graph is f of x. And then we have g of x on our table. X, okay, g of x, x comma y. So we're interpreting the information. Okay, so find the value of this whole thing. Okay, 3 times 2 times f of negative 3. So f of negative 3, we got to go to the f graph, go to negative 3, find the y value. It's on 4, okay? Minus 4 times g of 0. Go to the table for g. 0 is the x. So g of 0 is negative 3. Now that we've substituted, we can use PEMDAS. 3 times 8 plus 12. 3 times 20, 60. Okay, there we go. Now the next one. Given h of x equals ax squared minus 4x, what values of a is h of 3 equal to f of 2 minus g of negative 3? Okay, let's find f of 2. So going to the f graph, 2 is right there. 6 minus negative 3, g of negative 3, so got to go to g again, which is 1. So h of 3 equals 6 minus 1, which is 5. Okay, now we know two important things. We know h of 3, and we know it's equal to 5, okay? So what do we do with this information to help us solve this equation? Remember, it's h of x, so the x is the 3, so we can say h of x equals ax squared. I'm just rewriting it first, minus 4x. Okay, we know x is 3, so let's replace our x's with 3. h of 3 equals a times 3 squared minus 4 times 3. Now we know the entirety of h of 3 equals 5. So let's replace h of 3 with 5. So 5 equals, simplify this, 9a minus 12. Now we can solve for a. Add the 12. 17 equals 9a. Divide by the 9. A equals 17 ninths. There we go. We found a. Okay. Good. Continuing with comparing things. Okay, this was comparing different graphs. Okay. Now we're going to compare graphs. Sorry. This up here was comparing tables up here. We're comparing tables and a graph. We're down here, we're comparing two graphs in one coordinate plane. Okay, so I always like to highlight my two lines. G of x is here. So I'm going to highlight g of x, follow it around so I don't get confused. There's g of x. F of x is here, so again, highlighting this around so I don't get confused. Okay, there they are. Now we can use our graph to help us with the information it's asking. Okay, domain of f of x well, the arrows go on left to right forever. So negative infinity to infinity. That was the purple line. The blue line, g of x, also goes on forever in both directions. So also negative infinity to infinity. Okay, not bad. The values of x such that f of x equals 0. So if f of x equals 0, remember this is saying y equals 0. So y equals 0 is the horizontal line here, okay? And we're looking for where f is hitting the 0, which is right there on negative 9. So x equals negative 9, or negative 9, 0. Oh, but it's just asking for what values, so we don't need to put it as an ordered pair. Okay. Now it's having us find the same thing, but for our g of x. So g of x equals 0. So here, here, and because our line is going down, I'm going to follow the slope. Up 1 over 2. Okay, there's one here. That's at 12. Okay, normally I wouldn't have you do this, but we will need this in a little bit, so we do need to find it. So it's at negative 6, negative 2, and 12. Okay, there are the x values. The values of x such that f of x equals g of x. Okay, remember f of x equals g of x is an intersection. So where do our two lines crisscross each other? They are here, here, and here. Okay, we've got 3 of them. So the first one is at negative 8. The second one, I'm going to estimate 1.2. And the last one, 9. Ooh, no, 7. Okay, there they are. So that is where x equals each one of those. Okay? Now, the values of x such that f of x is bigger than g of x. So we're looking for where f is over g, on top of, lies above. Okay? Above. So f is above here and here. Okay? That's where f is above. So we write it like an increase, decrease. Okay? So it's from negative 8 to 1.2 and 7 to infinity. Okay? That is where it is above. Our next one is asking where it's below. So f is below g. F is below g down here and here. Okay, so that's from negative infinity to negative 8 and 1.2 to 7. Okay. Good stuff. Going to erase. Dang it. Okay, I'm going to erase all of it, and then we're going to, restart. Let me erase everything. Because otherwise it's going to get really a lot. Okay, so. Okay, we've got g of x and f of x. Okay, now let's keep going. So where is g of x greater than 0? So g of x needs to be above our line here of 0. So where is the green above 0? It's here and here until, remember, it reaches the 12. Okay, so we've got it's greater than 0 from negative infinity to negative 6, and then from -2 to 12. That's why we needed that 12. Normally, I would make sure the graph is complete for you, okay? Okay, now f of x is below. So now we're looking at it below 0. So f of x is only below 0 right there, that little piece. So what is that? -infinity to -9. Okay, increase, decreasing, and constant should be familiar to you. So increasing for f of x, we're looking at the purple line, is increasing from -infinity all the way to here, so -7. Increasing again from here to here, so -4 to 0. And one more time from 4 to infinity. There we go. Okay, is g of x constant? It is constant from, g of x is our green line, here to here, -1 to 3. And where is g of x decreasing? So going down all the way to there. So -infinity, what was that? -4. And then going down here. 3 to infinity. Okay. The values of x such that f of x is greater than 0. So back to, okay, I'm going to erase it again because we got a lot happening again. Okay, so re-highlight my lines. F of x, g of x. Okay. F of x is greater than 0, so anything above here. Highlighted weird. Okay. There we go. Okay. So, what was it? F of x? F of x. Okay. F of x is our blue line, so it's greater than 0 from here all the way to infinity. Okay, so -9 to infinity. And then the values of x such that f of x is decreasing. Okay, so f of x, our blue line, is decreasing from here to here and here to here. So -7 to -4. And 0 to 4. Okay, interpreting isn't hard. You just really got to pay attention to what you're looking at. Having different colors can be super helpful, so make sure you do that. That is the video for today. Have a great day.